Africa, the cradle of humanity, is a continent of immense diversity. From the bustling Medinas of Marrakesh to the sweeping savannas of the Serengeti, it is a land of breathtaking beauty and profound cultural heritage. Yet beneath this vibrant tapestry, a dramatic geological transformation is underway. The African continent is, quite literally, splitting in two. This monumental shift is happening along the East African Rift System, a vast geological fault line that stretches over 3,000 kilometers from the Red Sea in the north to Mozambique in the south. Over millions of years, this slow but relentless process will reshape the geography of our planet. To comprehend the forces shaping Africa's destiny, we must delve into the heart of our planet. Deep beneath the Earth's crust lies the mantle, a layer of hot, viscous rock. This molten rock churns slowly, driven by heat emanating from the Earth's core. These convection currents in the mantle exert immense pressure on the tectonic plates that make up the Earth's outer shell. The African continent sits atop the African tectonic plate. However, this plate is not a monolithic entity. It is in fact fractured, with a divergent plate boundary running along the East African Rift System. As the plates continue to pull apart, the land in between collapses, forming the characteristic Rift Valley. The ongoing splitting of Africa has profound implications, not just for the continent itself, but for the entire world. This monumental geological event will redraw the map of our planet, creating new landmasses and altering existing coastlines. The most immediate impact will be felt in East Africa, where the Rift Valley is most prominent. As the rift widens and deepens, low-lying areas along the coast will be submerged, leading to the displacement of coastal communities and the loss of valuable land. The Horn of Africa, the triangular peninsula that juts out from the easternmost edge of the continent, will be particularly affected. As the rift widens, this region, which includes countries like Somalia, Ethiopia, and Djibouti, will eventually break away from the mainland, forming a large island in the Indian Ocean. The formation of a new ocean basin will alter ocean currents, affecting weather patterns and marine ecosystems worldwide. These changes could have significant implications for agriculture, water resources, and human settlements in different parts of the world. The geological drama unfolding in Africa has particular resonance for India, a landmass intrinsically linked to the African continent by history, culture, and now, a shared tectonic fate. The Indian subcontinent was once part of the supercontinent Gondwana, which included Africa, South America, Australia, and Antarctica. The breakup of Gondwana, beginning around 180 million years ago, set in motion a chain of events that ultimately led to the formation of the Indian Ocean and the collision of India with Asia. Today, India and Africa are separated by the Indian Ocean, but their tectonic destinies remain intertwined. The same forces that are pulling Africa apart are also pushing India northward, driving its ongoing collision with the Eurasian plate. This collision is responsible for the uplift of the Himalayas, the highest mountain range on Earth, and for the frequent earthquakes that plague the region. As Africa continues to split, the Indian Ocean will widen, pushing India further northward and intensifying the collision with Eurasia. The environmental repercussions of Africa's tectonic drama extend far beyond shifting coastlines and altered ocean currents. The very ecosystems that thrive on both continents hang in the balance, susceptible to the ripple effects of this monumental geological shift. As the African continent continues to divide, the delicate balance of its ecosystems will be disrupted, leading to both challenges and opportunities for the species that call it home. The East African Rift Valley, a biodiversity hotspot, faces a particularly uncertain future. Home to a unique array of plants and animals found nowhere else on Earth, this region is already grappling with the impacts of human activities, such as deforestation and habitat fragmentation. The ongoing rifting, with its associated volcanic activity and earthquakes, will exacerbate these pressures, leading to further habitat loss and fragmentation. For some species, the changing landscape will bring about new opportunities. The formation of new land masses and the isolation of existing ones could lead to the evolution of new species, as plants and animals adapt to their changing environments. Gazing into the future of a continent dividing is an exercise in imagining the unimaginable. The geological clock, ticking at a pace unfathomable to the human mind, promises a future where maps will be redrawn and coastlines reshaped. While the precise timeline of Africa's split remains shrouded in the mists of geological time, the eventual outcome is clear. A new ocean will emerge, cleaving the continent in two and forever altering the face of our planet. This monumental geological event will usher in an era of profound change, not just for Africa, but for the entire world. The emergence of a new ocean basin will reshape global trade routes, opening up new maritime passages and potentially shifting economic power dynamics. Coastal communities on both sides of the nascent ocean will need to adapt to the changing realities of their environments, facing challenges such as rising sea levels, coastal erosion, and increased storm surges. As witnesses to this unfolding geological drama, we are tasked with a profound responsibility. The rifting of Africa is not merely a scientific curiosity, it is a harbinger of change, a reminder of the dynamic nature of our planet and the forces that shape its destiny. It underscores the need for ongoing scientific inquiry, for it is through research and observation that we gain a deeper understanding of these complex processes and their potential impacts. Monitoring the rifting of Africa is not just about tracking the movement of tectonic plates, it is about understanding the interconnectedness of Earth's systems. This knowledge is essential for informing policy decisions, mitigating potential risks, and adapting to the challenges and opportunities presented by a changing world. The choices we make today will determine the legacy we leave for future generations, shaping the world they will inherit.